In this video, we're going to solve the 2008 Form A AP Calculus ABFRQ question that says concert tickets went on sale at noon, t=0, and were sold out within 9 hours. The number of people in line to purchase tickets at time t is modeled by twice differentiable function. That's important whenever they say twice differentiable. So, twice differentiable. Okay, for 0 is less than or equal to t, which is less than or equal to 9, values of t at various times t are shown in the table above. Use the data in the table to estimate the rate at which the number of people waiting in line was changing at 5:30 at t=5.5. Show the computations that lead to your answer. Indicate the units of measure. So if they want you to find a rate, basically it means find the slope. So it's going to be between these two times, 7 and 4. So when we do this, we're going to do L of 7 minus L of 4 over 7 minus 4, and this is what 5.5 will approximately equal L prime of L 5.5. So now when we solve this, L of 7 is 150 minus 126 all over 3. So 150 minus 126 is 24 over 3, and that's going to equal 8 people per hour. Okay, part B. Use a trapezoidal sum with 3 subintervals to estimate the number of people waiting in line during the first hours that tickets were on sale. Okay, so let me scoot this up. So now we have to use, I made that too big. We have to use trapezoidal sum. So how do you find the area of a trapezoid? Area of a trapezoid is equal to 1/2 the height b1 plus b2. And we want to find the average of this. So the average of this during the first 4 hours, we're basically going to use this part over here. I know it's hard to see. So we're going to do 1/4. Now we have to figure out our height. Let me scoot this down so we can see it. So our first height is 1 minus 0. It's here. 1 minus 0. So that's going to be 1 and plus 120 plus 156 all divided by 2. Plus the next hour is going to be 3 to 1. So how tall is that? That would be 2. So this would be 2 times 176 plus 156 divided by 2. We're following this formula right here. Plus now this would be the last one. 4 minus 3 is 1, so that's how tall it is. 126 plus 176 divided by 2. This is a calculator question, so you could use your calculator. And when you solve this, you should get 155.25 people. How do you have 0.25 people? I would say 155. I would round it, but I would show your work. Okay, part C. It says for 0 is less than t, which is less than or equal to 9. What is the fewest number of times at which L of t must equal 0? Give a reason for your answer. So what you need to do over here is you need to find the slope of both parts. This is where the twice differentiable part. Since it's twice differentiable, MVT applies, EVT applies, mean value theorem and extreme value theorem. So what's the slope here? Our slope here would be 156 minus 120 over 1, which would be 24. Now, let me change color so we could kind of see what I'm doing. Now, what's the slope here? It'd be 176 minus 126 over 2, which would equal, what's that, 50? 50 divided by 2 is negative 25, if I did it right. So this would be a spot, because it definitely went through, it definitely hit a slope of 0, because MVT would apply, right? So let's do the next one, somewhere in between there. So let me change color so we can see. So now we are doing, what, did we do that one? No, we didn't do, crap. I skipped one. I should have done 176. No, I did do that one. So it's 126 minus 176. My apologies. 126 minus 176. All over 1. So this is going to be negative 50. It did not change there because it's still negative. Okay, next one would be, let me go to white. This will be kind of hard to read, or at least where I kind of underlined it, 150 minus 126 over 3, which would equal 8. So it also happened here. The signs changed, and now the next one would be, running out of colors, let me try gray. So next one would be 80 to 150, this part right here. So 80 minus 150 over 3, which is negative 70/3. That's another spot. And now the last one, let me go back to that green, would be 0 minus 80, so negative 80 over 1, which is negative 80. It does not apply there. So now, according to this has to happen at 3 spots. It happened somewhere in between here, somewhere in between here, and somewhere in between here, because the slope went from negative to positive, negative to, well, it went positive to negative, positive to negative, negative to positive, negative, negative to positive, positive to negative. So it definitely happened at 3 spots. Part D. The rate at which tickets were sold for 0 to t of 9 is modeled by R of t equals this function over here, tickets per hour. Based on the model, how many tickets were sold by 3 p.m. to the nearest whole number. Very, very easy question. If you want to answer this, you just integrate 0, 3, RT, dt. Take out your TI-89, type it in, and you should get about 972.784. So 973 tickets were sold by 3 p.m. And I hope this video helped.